Hello, and welcome to a video episode of Cyberdeck Users Weekly. I'm Paul, and I wanted to do something a little different today. The last time I did programming on here, I did like a speed run of making your own website, and I think that's really cool and it's really important. But something that's a little more topical right now is encryption. So, specifically warrant-proof encryption, as if that's a thing. It's like you made a door for your house that stops us from serving you warrants effectively. But nobody tries to get us to have like paper doors so that they're easier to break down. Anyways, this is a huge argument that's been going on for a long time about whether it should even be legal to encrypt things. And what's interesting about this new law, I don't know if you've seen the news, but there's a new law proposed, which, hey, really does no indication of actual what will actually happen. But this is also something that Attorney General Bill Barr has been pushing for, of getting companies to put backdoors into their encryption to allow the government, for only for lawful purposes, of course, to break open encrypted messages. And I'm not going to get super into the debate of it. I want to have a little more technical angle in this video, but the thing that really sticks out to me is this is so I just totally lost my train of thought. The thing that sticks out to me about this is that this is really focused on companies. Now, there was a time when encryption itself was illegal to export. It was labeled as like a munition. And therefore, don't read this T-shirt if you're outside of the U.S. Don't export this T-shirt. This shirt is classified as a munition, may not be exported from the United States or shown to a foreign national. And this is RSA encryption. But the munitions T-shirt people won. And we have encryption, and it's widespread. But what's interesting is that we get a lot of our encryption. I like that this website was probably made before HTTPS. We get a lot of our encryption from companies, right? And so while encryption is just math and software, and therefore is really free speech in a sense, or would be, classified, I believe, still in a reasonable court as free speech. This law doesn't really have to engage with that because it's just coming after companies who provide encryption. And there was an interesting, I was reading the law. Decrypting or decoding information. So this is what, basically, as far as I understand the law, if there is a warrant, then there's a directive, like they ask the company to assist in decrypting. So that the company should isolate the information authorized to be searched, and then help decrypting or decoding information on the electronic device or remotely stored electronic information that is authorized to be searched, or otherwise providing such information in an intelligible format, unless the independent actions of an unaffiliated entity make it technically impossible to do so. So I don't know if this is the best name. I actually would like some other thoughts on naming this, but I have started and made a folder. I made a little Rust project called unaffiliated crypto. So I want, instead of sort of raging against the machine of a government that will, were this to become law, would almost assuredly, if not on day one, then definitely by day two, abuse it and use it to spy on American citizens, which is something that they already do. They just want to do more of it. You know, like if the government was angels, right? If they were the best people ever, and they were perfect somehow, and they abided by the things that are written down as law, then possibly this could be a good thing. You'd have real good people spying on Americans to make sure that their Americans aren't doing bad things. But that's not how this stuff gets used. I'm just very confident that it would be abused. But the nice thing is that I kind of, in some sense, don't need to worry about what they think, because I'm an unaffiliated third party, unaffiliated entity. And cryptography is just math and software, and it's speech in a way. So I made this Rust project, and what I want to do is kind of have a little series where we go through encryption, and it's a lot of it's for my sake. A lot of cryptography stuff is not very understandable to me, or it's not like it all goes over my head. I feel like I've read enough about it that doesn't go over my head anymore. It's hard to it's like holding, you know, sand. It's like it's hard to really have a firm grasp on and really feel like I really understand it. So I feel like by doing this little project, and I've kind of got multiple steps. I think this will be multiple videos. I know this will. I know that this video will not be all of cryptography. That's for sure. We can understand. Well, one, I would also like people who are listening and watching this to get involved and read this code and follow along and do pull requests. Like I will take any pull request for like a typo or a refactor, or you can just add. I'll make like a contributors text file that you can add to. But yeah, so I want to make this as a demo of basic cryptography things. So today will be hashing. Then I want to do signing and verification. Then encryption and decryption. So that's where you get some real secrets going on. And then hopefully maybe even get to like Diffie-Hellman key exchange and like messaging. It'd be cool if someone could take this as a little toolkit to do real simple cryptography stuff themselves. Like, you know, if you had invisible ink as a kid, you know, and you could hide messages. And so this won't be these won't be the best tools ever to do these things, but I feel like by building these together and really understanding what's going on, we're in the camp that really understands that this is not just a product that someone else has to provide for you to have encryption and security. These are theoretically tools that you could build yourself if you needed to or wanted to. So that's my thinking behind this. Let me know what you think. So the first thing we're going to do, oh wait, I've got this fancy new Z command I learned. There we go. Thank you, William. Okay, so I have, this is the little older version of Bitcoin. And then there's this SHA-256 sum. So we're going to learn hashing. So when you take a file, and I can pull up cryptographic hash functions. Let's see. I can't really zoom in on my terminal, but I can at least zoom in on web pages. So a hash function. This is like a basic building block of a lot of cryptography. And so it's also really simple, or it's pretty straightforward. So I think it's a nice little place to get started. So you've got an input It goes through this function. Like, just think of this as a fancy machine. This is a black box or whatever. You put stuff into the cryptographic hash function and you get out this hash digest. There's some important properties. One thing is that these digests, they're always the same length, but their specific content is different based on what the input was. And if you change just one tiny thing, like here the V changed to a U, you get a way different output. And a good, these are called a one-way function. It's important that it's kind of hard to take a specific hash digest, an output, and figure out what input would produce that specific output. So this is why hashing is used in Bitcoin, because you have a block of transactions. Like my transaction is the red fox jumps over the blue dog, and that hashes to this. So if someone knew this hash but wanted to change the block so that they would get actually the red fox jumps over the blue dog and pays Paul 4 Bitcoin. You know, I'm the bad actor here. Paul is the bad actor trying to change the input but get the same hash out. That's kind of mathematically impossible, or it's going to take a few million years or whatever to pull that off. And the other thing is well, and there's a lot to hashing, but that's one of the ways it's used. And so why I have the Bitcoin software here is that hashing is also used to verify that a file hasn't been modified. So if we have this SHA-256 sums.asc file right here. Let's see. So this is a list of SHA-256 hashes of these zip files, basically, right? And there's different versions. So there's Arch64 Linux. I think that's the one I have. Let's see. No, I have x86. There we go. Oh yeah, Arch is ARM. So this would be like on Raspberry Pi. I don't know. Windows, OS 10. So this is the one I have, which this file, which is a big file, hashes to this string of characters, this hash digest. And if someone tried to make a modified version of this file and distribute it to me, but it's like secretly steals my Bitcoin when I'm running this software, they could try really hard, but they couldn't get it to have this same hash. And so when I download the software and then I hash it, I put it through a hash function, right? If I don't get this specific hash output, then I know that it's not the official release. It's been modified. Something's different about it. I don't know what's different about it, but I know something's different about it. Now, in addition to this list of hashes, one for each of these downloads, there's also a signature here, a PGP signature, which is something I don't know a ton about, but that's going to be the next signing and verifying. So because what if the bad guy distributed a version of this SHA-SUMS ASC file with their hash for this download, right? Well, that would obviously defeat the purpose of me hashing and seeing what the output is, because they've also modified this hash. Obviously, these are a lot cheaper and easier to distribute. Someone could tweet this hash saying, if I trusted them and I trusted Twitter. It's all about who you trust and who you can trust and who can be verifiably trusted. But this signature is from a known good key that signs this message saying that this yeah. We'll get into signing verification next. But this is a signed message, and so if I trust the signature, then I can also trust like that this is from the right people. Then I can trust that this hash is right. And so if this hashes to this, then I know that this software is from the people I wanted to get this software from. I hope this makes sense a little bit. So it's pretty easy on Linux. This will probably look a little different on Mac and Windows. Just depends on what you have installed. But this, I think, came with my system. I'm on Pop OS. So if I run the cryptographic hash function SHA-256 on this binary, or this zip file, 5FCA9, 5FCA9, yada, yada, yada. E4C, E4C. So these are the same. So this file that I have on my computer is hashing to the same thing it's supposed to hash. So I can be pretty sure that this is the real copy of Bitcoin that they were trying to distribute, and then they signed this message. If I trust this file being accurate and this message being signed. So that's, again, we'll get to signing and verification next time. But now we're just going to deal with hashing. So let's re-implement SHA-256 in Rust, because this is just code and math, and we can do it ourselves. Now, to be honest, I'm not really actually going to do this from scratch. I'm going to use a library to do most of this work for me, but I feel like we'll still learn something from this. Okay, so I'm going to add a couple of dependencies. There's a cargo. This isn't built in with Rust, but there's this nice cargo add utility I really like. So SHA-2 is the Rust crate of the SHA-2 cryptographic hash algorithms, and there's a bunch of them. There's SHA-256, which we're using, SHA-512, etc. And they've got examples of how to use this. The other one, they're using hex literal, but I've been using hex view, which, yeah, I'm not, like, basically you end up with hexadecimal. I want to display this as a string, not just as binary information. So, okay, so let's go to our project, and so first we need a command line argument, basically. So we're going to get a vector. Oh, by the way, I meant to mention this earlier. So I was thinking about maybe doing a tutorial on Rust, just in general. And the Rust book is really good, and it's a pretty good structure for learning programming, I think, in general, but obviously it's learning Rust specifically, and it helps a lot if you already know programming before you read this book. But if you don't, I think you could still pick it up. So if people are really interested in that, I might be down to go through some of the chapters of this book as videos for people to learn Rust. But what I'm going to do now is not explain all of Rust, but I'm just going to explain how I'm using Rust as I'm going along. So if you are pretty familiar with programming, you might this might make sense. If you're not, it might be a little tough to follow. So I would recommend starting reading this book and then asking me if you'd like to. I can make some videos on learning Rust. So basically, I'm getting the arguments from the command line. We need to import env. So when I ran SHA-256 sum, so this is the program and this is the argument to the program, right? So this is going to get the list of arguments and collect them into a vector. And I'm just looking at my cheat sheet here. So if we forget to pass an argument of the file that we want to hash, then let's say need a file to hash and return. So that just ends the program because we're in the main function. This is, if you haven't done like systems programming, like this is, we're not in JavaScript, right? So this is the application. And when we return from the application quits. That's the end of it. So, and this counts, even though it's the name of the program, counts as the first argument. So we want the second argument. And so we need 2 arguments. So if it doesn't have 2 arguments, then we're just going to quit. And so we'll say that the file to hash is args1. Okay, why it needs to be a reference to args1. So the second element of the arguments vector is going to be our file to hash. And so let's just print that out. So this is like console log in JavaScript. File to hash. And that'll work. Okay, so let's see. Cargo run. Need a file to hash. Okay, let's give it an argument. So let's pass it Bitcoin. Okay, it printed out the name of the file that we want to hash. Cool, cool, cool. All right. So now the hashing part. So we're going to use these fancy libraries we got. So SHA-2, the SHA-256 algorithm, and digest is I don't know how to explain it. I don't really understand it. But you need a digest to, it's like the, I don't know, it's the machinery. So we need some stuff from the standard library so that we can read the file. These are just importing various functions. So these are obviously from those 2 libraries that I cargo added. You can see them in cargo.toml. These are our dependencies, SHA-2 and HexView. So I'm pulling those in to do my work for me. So let's make a function called hasher. It will take in a path. And we'll return a result because this could fail, like if it can't find the file or whatever. And the result will be a string, and the string will be like a stringified version of the result of the hashing. So we're going to open the file using Rust's like file standard library stuff. And then, so if that's successful, right? We're going to pass a closure and we're going to do this. We're going to do some stuff with the file. So we're going to get a mutable version of the file, which I don't know why it needs to be mutable. But, yeah, maybe I'll try doing it without mutable, see what happens. So yeah, if you've ever passed a closure in JavaScript, so this is like an immediately invoked function right in here. And move means we're moving our environment into here. So we're going to create a buffer and we're going to fill it with zeros. I forget where I even copied this style from, but I saw somebody do hashing like this. I don't know if this is necessarily needed. Let's see, how are they doing it over here? They just create a hasher new, then they update it with the input message, then they finalize, and then they return. See, I don't even know why I need this buffer. Wow, this is quality tutorial material. I don't know, I did it like this before, and I'm copying some of my older code, and so I'm just going to go with it. So we're gonna read. Oh, maybe it's because you don't want to like read like a huge file all at once, right? That's why. Duh. So this is like 1024 bytes, 1024 bytes. So that's like 1K basically of memory that we're gonna like write to. We're gonna read into that little buffer, and as we read the bytes, like, you know, it's all zeros and ones to the computer down underneath, and then the hashing algorithm looks at those zeros and ones and hashes them. But the cool thing about it is it's deterministic. If you give it the same series, oh yeah, and then if we get to the end, then we break out of this loop. It's deterministic, so every time if the series of zeros and ones are exactly the same, you'll get the exact same hash output. And if they're not, it will be vastly different, which is an important thing with hashing. It'll likely be vastly different. So we've got this hasher, which is a SHA-256 hasher, and it's taking in little bits of the file that we're inputting over and over and over and over until it gets to the end, and it's updating its result, right? If it stopped at halfway and then you ran it again and you stopped at the exact same spot, you'd get the same hash as well. So we're gonna do that, and then see, we're going to return a result. So we're going to say everything went great, so it's okay. A result can be an error or okay and the value that you wanted. So in this case, it's okay, and we have the value we want, which is a string. So we're going to format a string, do some fancy formatting. Forget what this X is. Rust standard string formatting. I think this might be hashing. Oh, it's like debug with hex. Yeah, if you really wanted someone that can explain the hex to you, you really came to the wrong video. And so anyways, but we're gonna do the hex view of this. Let me just pull up the hex view library so I can remember what this is doing. Oh yeah, so we have like a buffer, right, of just binary stuff, but we want to view it as hex. So these are just a series of bytes, and that wouldn't look like what you expect a hash to look like. So we finalize the hash. And now we're done with the file open, and now we're done with our hasher function. So let me see if I can help explain a little bit of this stuff a little bit. So this finalizes, then we take it as a slice. Let me just try it without taking it as a slice. Yeah, so this is generic array. Yeah. Which isn't good enough for us right now. So we need to have it as a slice. Wow, I don't know if this video is very good. All right, we have a hasher function. And so what does it do? It opens the file of the file path we gave it. And then, so basically, if that's okay, if it successfully opened that file, then it moves that file into this function here. And it creates this little buffer so that it can read the file incrementally instead of having to read it all at once. And it creates a hasher, which is sort of going to slowly build up its result of the final hash. And then in a loop, it reads the file into the buffer. If it's done reading, it breaks out of the loop. And if it's not done reading, then it updates the hasher with that little section of the file. And then once we're out of this loop, so we found the end of the file, then it returns this string format, just turns something in, like creates a string, like it could say, oops. If you've ever done like template strings, it's kind of like that in JavaScript. The hash is, okay. So that will return a string. So now we just need to call that function with our argument that we passed at the first. So we're going to match on the result we get from the hasher because it could be okay or it could be error. So we're going to take, we need to create a path out of the argument string. And if it's okay, then we got our hash and we'll just print it out. And if it's an error, then let's say what happened. So we'll print out, this didn't work because error. I think that could be an ePrint line. So print out an error. Okay. This actually bothers me. This hash is for, this is dumb. You know what's going on. Okay. So we read in the file name of what the path to the file that we want to hash. We get that argument. Then we hash it. So let's see what happens. So let's cargo run. Okay, it says it needs a file to hash. So cargo run, and now when you're in this like command line setup, or within the development stage, you have to do like -- to pass arguments. Bam. And you notice that took a little bit long. Took a little while. Like if we do SHA-256 sum again, that's way quicker. But if you do cargo run release, so this is like, so we were running in debug mode by default. This is the release mode, so it's like actual optimized code. That goes very fast. I don't even know who's faster. I think I'm faster. And if you look, 5FCAC9416E48. And we've got our SHA-256 sums. 5FCAC9416, right? I guess that's why I wanted to do this. I know that this wasn't the best Rust tutorial or SHA-256 hashing function tutorial, and definitely didn't explain hex, but it feels cool to write this code. Obviously, I'm standing on the shoulders of the giants who actually do the important part. But I can just write some code and I can get this same result as, you know, a built-in utility in Linux. Like SHA-256 sum is a well-established, mathematically consistent. It's an idea that exists. You can't kill this idea of what a SHA-256 sum is. So, this is not going to solve everything in this law, but this is an important building block of a lot of cryptography, especially modern cryptography, is hashing functions. And so I feel like we're one step closer. I have also, the reason I was copying this code is because I wrote this a little while ago as a Druid project. I'm sure I've so this is a graphical program that does the exact same thing. And I feel like I've already gone a little longer than I was hoping to. But I think what I'll do is I'll try to keep these tutorials real simple, but I'm also probably going to be pushing up code that does the same thing, but in a graphical user interface, because, a lot of people are scared of the terminal. And as much as we want to be comfortable in the terminal so that we have the power to have, to be unaffiliated entities, it's also nice to be able to distribute that ability to other people. And I think graphical applications can be a good way to do that. So this is running in Druid, which is a project that I contribute to and really enjoy, and I really think of as like a good way forward for making user interfaces in Rust. And it's doing the exact same thing, and it's getting the exact same result as this is. It's looking at that Bitcoin binary and hashing it, and look what comes out. So that's the idea. That's writing a hashing. Well, we're not writing a hasher. We're calling a hasher that does the hashing for us, and we're showing the result. But we end up with the same result as anybody else who wanted to hash this specific file signed by this signature. Cool. All right. That's it for now. Let me know what you think, how we could work together most effectively on this project. But yeah, I'd like to end up with, at the end of this, a small library of tools that are a fun way to play around with cryptography, but people who read the code or write the code use it as a way of understanding cryptography and becoming unaffiliated. All right, well, have a good weekend, everybody. And I'm going to be traveling for a few weeks, so my output might be a little random. I might just focus on this project because it's really interesting to me right now. So yeah, have a good one, Paul.